Okay, so now I want to go through maybe a slightly more complex example, not much more complex though, and make this cabinet or something very similar. So to set that up, I'm going to maybe go a little bit further with some of the other tools you've been using. And so hopefully you're getting more comfortable with these tools, but I'll just go through very quickly the floor tool. So I've gone to the ground floor plan, and if I now go to make a floor, just clicking on the floor button, I'm going to just show you that in the draw panel, it's got pick walls already selected. So I don't need to change that, but I just want to make sure that it's clear that you're using, I'm using pick walls, and I can pick the inside of those 4 walls. And remember, of course, just like those solids we're making, I have to close the shape to make it, again, a closed shape or a profile. So with the trim to corner tool there, I can choose these 2 lines, and then the 2 on the bottom left, and then the 2 on the top left. Tick to finish. And so now that you've seen the join tool, what do you think this tool is? Yeah, well, what it's asking me is, do I want to join the wall to the floor that I've just made? And once you've started to use that join tool, it becomes a lot clearer what it's doing. It means that if you say yes, you don't have to go and choose join and join those things yourself. So that's good. It saves you time. So yes, if it asks you about joining, I'd recommend just say yes every time. And I'll quickly show you what that looks like. If you look in a section now, because they're joined, it's just this little thing, which you might think isn't that important, but again, those picky architect type people will pick you up on that. If it's not, if it's too heavy, they'll notice. So back to the ground floor plan. And then again, I'm just going to draw some walls in, so I've got something to fit my cabinet into. So here, I've gone to the ground floor plan again. I'll click on the wall tool. And because we're still at the early design stage, I'm going to use a generic 100mm wall, and then very roughly draw in the wall around the WC there. And then I'll do another wall over here. Now, when you're doing your own, take your time and use more exact measurements than me. Just doing this roughly, so you get the idea. Now I think about it, even here, I'll spend a bit more time on it because I don't have to make all of this again. So I'll show you another good option. So with this design that I'm trying to make, you can probably tell already just by looking at that space, I'm doing a slightly different design, but it's going to be following this sort of approach. That there are really 4 main sections there that will probably be even. So, using reference planes, I can set that out. So I'll draw 1, 2, 3 reference planes, so that I've got 1, 2, 3, 4 sections between them. And then to make them equal, I use the dimension tool. Choose 1, 2, 3, 4, 5 reference planes, and then find the equals option. So now, if I've got those reference planes, I can adjust the walls accordingly so that they follow or snap to those. So hopefully that will make a bit clearer why reference planes can be so useful for setting out your divisions and other important dimensions. Oh, so you need to select the dimension and you'll see the equals option. Okay, so I'll also then now measure, maybe to see the length of this WC room. 2175, that's just okay, so that'll work. And then here between these two walls, yep, same thing. So that'll work for my vanities as well, my vanity unit. I'm doing a double vanity there, so that's a good size for it. So now I can start modelling. So again, back to model in place. And this time, another good tip I can give you, Casework is the category I'm going to use. Casework. So it's a bit of an American term. Here we'd probably say joinery more often. So you've got furniture as well. That's another category. But furniture's better for things that aren't built in. So chairs and other floating furniture work best with the furniture category. But for things that are built in, Casework. Built-in furniture, basically. Should all be done with Casework. So, okay. And now it's going to ask me for the name again. This time I'll put in a more meaningful name. Bathroom vanity unit. But again, the name's just for you. Click OK. And then thinking back to the way we used to make these things, I'll make an extrusion. This time I'll use the rectangle tool and give you an idea about how that works. So with the rectangle tool, I can go to the corner and then come across to give the opposite corner on the wall, but notice how it's snapping to different measurements there. Yeah, and it's actually hard to get it to give you what you want. And that's why sometimes I don't use the rectangle tool. But here, I'm happy to just let it be what it wants to be. There we go. And now, I'll press escape twice to get out of that drawing tool, and I can come back and select this line at the bottom. So really what I'm trying to show you there is that you shouldn't be trying to change it as you draw it. I might just show you again. So if I did what you might be thinking of and changed it straight away here when it gave me the measurement, I'll change it just to something else, let's say 400. Notice how it's brought the top line down. I don't want that. Yeah. So, and you can't know which side you want to move. So that's why it's always better to cancel and then select the line you want to move and then give the size. Yeah. So do you know the standard depth for a bench? You're on the right track? Yeah. Yeah, that's one on actually. Yeah, 550 to 600, but yeah, 560 is good. So that's good. Yeah, 900 is the standard height. 550 is what they'll tell you in the catalogues you can go down to, and some units are made for that, but it's not safe to do that because things like dishwashers and fridges as well that are made for kitchen benches usually are at least 600. They don't usually go down to 550. Even though I know they'll tell you in the kitchen catalogues you can do 550 or 560, but again, 600 is much safer. So that's a good starting point. So 600 is the depth the bench will be. Even though it's a bathroom, we'll do 600. But then we've got the lip of the bench, the overhang above the cupboard doors. Actually, it could be flush. I like doing it flush. But if you want to have an overhang, you can add that to the 600. You can come back if you want to, but it's often easier just to add it. And then also, we've got to set out for the kickboard. So underneath the kickboard, of course, being room for your feet, that's going to be set back behind the cupboard doors. So that'll be another 50 mil. So here, I'm making the kickboard. So I just want to explain, that's why I'm making this 550. That's going to be my kickboard depth, and then when I do the cupboard doors, I'll make them 600. So that's my kickboard. And have any of you seen what a kickboard looks like when they take the cabinets off? It's just a rectangle of timber. So it is. And so they use the same particle board or MDF or whatever you're using, melamine, as per the rest. So I'm going to offset that standard thickness, usually about 20 mil. It's not exactly that. If you look it up, there are different thicknesses, but 20 mil is okay. And I can just offset each of those sides inwards 20. You might be thinking, this doesn't matter because we're not going to see inside it. And that's true. If you were just doing this for perspective and for some presentation drawings, you might not need to model that extra thickness.
Did you tick before you offset?
No. So you can always go back to edit or just undo one step and it'll take you back.
So I've got that. If I go
Yeah, just undo. Oh no, you've got the sketch, so just use offset. Yep. And so with offset, you just need to remember to put the offset distance in on the options bar there. Yep. So again, this needs to be trimmed because those corners need to be joined. And is anyone thinking, why didn't I do a void? So if it's not clear, what I'm trying to do there is cut out the inside. And you could use a void. But I'm showing you another way here. We don't need a void because if you make a second shape inside, it cuts it automatically. And I'll just show you that. I'll put my depth in first. So do you know the height of a kickboard? Easy one to remember. What's the obvious measurement you would think? About that? 10, yeah, 100 mil. Yeah, 100 mil standard kickboards. And again, I always try to think back to the way we used to make these things. They sell you edging for kickboards. That's 100 mil. You can buy it from hardware shops even. So that's a good thing. And so here, tick to finish. And if we go in the 3D view, well, so you can see there it's cut the hole out. Just to make it a bit clearer, I'll go and take away the inside so you can see, let's go to thin lines so you can see the lines first start. So there you can see there's the inside. If I didn't have that, if it was just a rectangle, that'd be a solid shape. So it's almost like a void when you do that second shape inside. And that's actually fine. So here, that's the kickboard done, and that is literally how you would build the kickboard. So next, we'll make another extrusion. So again, remember I haven't chosen finished model yet, so back to extrusion. I'll do rectangle again, and again coming from the corner here, down to a point on the wall. I know it's going to snap to 600, so that's going to make my life a bit easier. But that's actually a complete fluke. It's because my wall is a particular size, but I need to still adjust that anyway, so it hasn't done all for me. So, well, again, just thinking through the construction, if we want the doors to be 600, the door thickness is going to be 20 mil. So this is the baseboard of the cupboard. The doors will sit flush up against that, so they'll be 20 mil less than 600. Okay, so 580. And now, in this case, we could model all of the different parts of the cabinet, but just to save time, and also because we're really approaching this more as a presentation style project than construction, I'm going to leave it at that, and I'll put my doors on the front of that. So what I'm saying is I'm going to make the carcass as a solid box, and then we'll come back and cut out the detail when we have time later. So do you know what I mean by the carcass? The carcass is the main shell of the cabinet, and the doors will go onto the outside of that. So then now looking at the depth, it's going to be starting at 100. So all of the others so far, they've been starting at 0, which means they start at the height of the level you're on, ground floor. Here I'm starting at 100 because I want it to start on the top of that kickboard. And then my end will be the height of the bench minus bench thickness, which is, let's say, it's 35 mil. Okay, so again, we'll just do, it's not standard for bathrooms, so we'll just do standard bench height, which is 900. And we'll come down 35, so that's 865. Tick to finish, and now into 3D, and we can see that new box on top. So back to ground floor plan, and I'll now make one last extrusion for the bench, sorry, not one last, another extrusion for the bench. So again with the extrusion tool, rectangle, and I'm going to just trace over what I've made and then change this line here to be 600 from the wall. So this is the bench top, and so we know it starts at the top of the last one, so that'll be 865 again, and then the top or the end is 900. So now again, tick to finish, back into the 3D view to check it, and we've got a bench sitting on top. But then what I really want to show you is, well, the two things, the void and also the doors. So I think I'll do the doors first, even though they're a bit more involved than the void. So, well, let's have a look at this drawing here. So we've got 1, 2, 3, 4, 5, and one of them's been deleted, 6 doors. I think should work pretty well there. I'm still going to measure it just to check, so I'll measure with the with the ruler. So it is 2125. Too late to do that in my head, so let's just. Well, can anyone do that in their head? 2125 divided by 6. That's not good. Okay, so let's try that one. Divided by. Sorry. Where's the backspace got here? 2125 divided by 5 should be a nice round number. 425. So, have any of you come across standard door sizes? It varies, yeah. 400 or 450 is used sometimes, but it varies. And it's only in those really standard off-the-shelf type kitchens that you'll get standard door sizes. When it's a bespoke kitchen, you'll often get different sizes, which is natural, so that they divide up into your bench. So here, 425, and then maybe we can allow a 5 mil gap as well between them. So I'll make it 420. And what do you think I'm going to use to help set out the spacing? Exactly, that's right. So reference planes here are going to help a lot. And so you've got this great option when you're working with model in place. Back on the Create tab, you'll see you can make reference planes. So they give you the right tools as you're using these other what are called sub-objects. So as long as you know where to look, you can go back to the Create tab, and then again with reference plane. So this time I'm going to have 5 doors, not 6. So I'll draw 1, 2, 3, 4 reference planes, which will give me 1, 2, 3, 4, 5 divisions. Using a line dimension again, going from the wall, reference plane, reference plane, reference plane, reference plane, wall. Click to place it, pickles. Okay, so then to check my my maths, so again we know it should be probably 425. If I measure now between the reference plane and the wall, okay, we've got that right. But then again, we're going to have that 5 mil gap. And, oh, what's happened there? I must have missed. Oh, did I drag that across? No, what happened? Oh, well, I've moved that somehow. I'll just fix that before I go any further. How did that go? Oh, no, so that was me. Let's go back. Okay. So I'll undo. That was, yeah, okay. So when I clicked equals, that's something to watch out for. Right, so when I clicked equals there, you can see that it's taken the bench. So you've got to watch out for that. And it's to do with a setting in the reference planes. It's a bit further than what I wanted to show you, but I will show it because here I'm going to select those reference planes now. And then you'll see there's an option in properties where it says weak reference, and I'm going to change that to not a reference. Which should hopefully stop that. No, it's still doing it.
So is weak reference the one in the middle of the wall?
Yeah, that's right. This one's... Yeah, well, honestly, I might have clicked on the... shouldn't be moving the ball. Let's just see. I might have clicked on the wrong thing. No, I didn't. This is Revit. Sometimes it does too much thinking for you. So, look, there's a bit of a trick there. I know I can fix it in another way, but I'm going to just put in another reference plane where the wall is. And again, this is a bit further than I wanted to go through, but it's not a bad thing if you see this. So I'm going to adjust this dimension so that it's snapping to the reference plane. And then now it's working. It's because I dimensioned to the wall. It's just one of those things. But so, yeah, look, it's something you get used to with Revit. And then now I can draw another extrusion for my door. So with the rectangle tool, I'll start by snapping onto the objects that I have. And then I can select, say, this line here and change that depth to 20. And then select this line on the right and make it, well, I'll make it 420. Okay, so that's brought it 5 mil back from this side. But that's still not done because it's a little bit further. You don't have to do this, but just again to give you some good pointers maybe, I'm going to select that rectangle, click move, and then just snap a base point, bring it over to the right, and type in half of 5, 2.5. Okay, and that's because I want it to be a 5 mil gap between this one and the next one, with that reference plane centered, in other words, 2.5 mil from the door. Still not perfect, but it'll look just fine.
Can you say how you get it?
Oh yeah, so I just selected the rectangle,
Yeah.
clicked move, and then click the base point, moved in the direction, and typed in the distance. Okay, so those things, again, if they're not obvious, as you use those tools become a lot clearer. So now I just need to set the extrusion start to the top of the kickboard, 100 mil, because the door should be flush with the bottom of the cabinet. And then the end, the top of the door, is the bottom of the bench, which was 865, but I'm coming down another 5 mil just so we can see a gap. Okay, and then finally I can select that rectangle and I'm going to click copy and tick multiple, and I'm going to pick it up on this corner here. Can you see how that's next to the door? Right, and we know that's 2.5 mil from the corner. And then I can come across and click on this centre line, and I know that it's placed at 2.5 mil to the right of that. And then coming across, again, this sort of set out, it becomes second nature after a while. I know at first it takes a while to get used to working with centres and all these different divisions, but I think it's just practice. Oops. Yep. Yeah, I ticked multiple just so I could keep repeating it. And but again, the most important thing when using that copy tool is whether you use that multiple option or not, it's always going to ask you for a base point to start with. So I used this point here as my base point to pick it up. So I'll finish that one and just again show you it in 3D. Well, actually, we'll have a look at it in plan first because you can see there it's not showing anymore. Why do you think it's disappeared? Exactly, that's right. That's good. So you're thinking in 3D, even in plan, and then now when we go to the 3D view, there it is under the bench. That's good. I'll go to shaded so you can see it like that. So you can see there why the gap is handy. At first, if you don't put the gap in, that's fine. But it's just a good thing to have for the look you want, probably. And then I'll go back to the ground floor now. And finally, do the main thing I wanted to show you, which is the void. Now, I needed to add something more in a certain way to show you that. So now, void forms, void extrusion. And so, I'm going to have the start there. I'll leave it on, I won't make it 100, I'll make it 200, or 300 even. Yeah, 300. So that's as far down as my sink should go. 300 off the ground, that's more than enough. And then the height, or the end, needs to be at least 900, because that's the top of the bench. But again, to give you another tip there, if you can make it higher still, then there's less chance of something going wrong. If we make the void 1,000, then we know it's definitely going to go through the bench and cut through all of those sinks. So that's a general principle in 3D modelling, that you, if you can, make things bigger than they need to be when it's cutting something else. So, and I'll show you that in a minute, what that'll do. So I'll just draw a rectangle for now. I don't know exactly the size of my sink, so I'm just going to draw a rectangle fairly roughly to get the void working. Tick finish, and then I'll show you in 3D. Okay, so you can see there how by having it a bit higher than the bench, it makes sure that it punches all the way through. If it was exactly 900, it should still go through, but you know, like a lot of software, a lot of programs, they're too accurate mathematically, and so there might be a sliver of bench top left there. You know, 0.0001 of a millimetre or something might be left. So again, if you can make it a bit higher, that's always good, just to make sure it does go all the way through. And so there we are. So you can see it's cutting the bench, but then also the carcass, it's cutting through but not all the way down, because we don't need it to go through the kickboard. So that's given me enough to make most of my vanity unit, but to finish it off, now I'm going to finish the model. I'll go back to the ground floor plan, and I'll get one of these other types of families that I've been avoiding for now, but again, just want to make it clear, model in place is what we've been using to make extrusions. Things from the library, they're families as well, but we use place a component for those. Load family, and I'll go to plumbing fixtures and find a vanity for the time being. So again, plumbing, architectural fixtures and sinks. And we've got some pretty terrible, to be honest, bathroom vanities. Well, I'm calling them vanities, they're sinks or vanity units. There are better ones in the other library that, well, you probably found already, but I'll show you again later. So for now, I'm just going to use this one. So I'm just going to place this by eye as well over the top of that void. I actually got it pretty close. God, that's a complete fluke. And I'll put another one over here. Now, they've disappeared again. Not a problem. Go to my 3D view, as you often will to find things. Select that, and then you can see over in properties why it is the way it is. And it might give you an idea about the standard height for for bathroom cabinets. That is actually more common, for 750 for bathrooms. But because I've done 900, there's no real rule. Some of the best bathrooms I've ever done actually had higher cabinets, so I'll make that 900. So that's better. This one, I'll do the same thing. Get in properties, 900. And you can see really clearly there the difference having the hole in the bench makes.
Can you use that object to cut through the other extrusion?
The void, you mean, or?
No. See how the second step
Yeah.
there's no hole
Yeah.
through the carpets?
Yep.
Can you use that stick to cut through the carpets?
Oh, no. Yeah, no, that's a good point, actually. So technically there is a way. You can put voids into families and then get them to cut things in a project. It's really buggy. So, yeah, that's never worked that well. Yep. No, that's right. It's just what you would do when you build it that you would need to cut. So if you're not cutting the bench in real life, then no. So, yeah, and so then also when you see even the shape of the void, it gives you a good idea how this would really be made. So, again, I'll select my cabinet and I'll just see maybe what you've been taking in. So what do I do now if I want to go and do another void? I've selected my cabinet. How do I get back to edit things? A couple of ways. No, so that's to make a new one. So yeah, that's, yeah. So how do I go back and add my void for the other sink now? Right, so I want to cut a void out just like this one. I want to cut it out of here. Exactly, that's right. So it usually gives you the tool. When you select an object, then you'll see the option to edit it. So that's what you should be looking for. That's good. So yeah, so select in the cabinet, then I can see I've got edit in place as the option to edit what I've made. Now, we've got all the same modelling tools as before, just like I was going to make it again. And back to my plan view. And I'll make a new void extrusion. And I'll just draw a rectangle. And now that I've got the sink there, it's much easier for me to draw the shape it would be in reality, which would probably be still a rectangle cut out.
So we could have done the same way for the first one, right?
Yeah.
Place the sink first and then the void.
Yeah, normally you would place the sink first. Yep. Yep. So there you can see that the cutout doesn't need to follow the shape of the sink exactly. And when they're building, that's not what they do either. They generally just cut out rectangular holes where possible because it's much easier than cutting a curve. Yeah, you can't, sometimes you do have to do more complicated shapes, definitely. You can't always do a rectangle, but if it's possible, that's much easier, as long as it sits under the lip of the sink there. Right, and so here you can see that clearly does. It remembers the settings from before. So it's done. We go to 3D. Here we are. But then you might remember the other one wasn't exactly right, but it's fairly easy now to find that void, because remember when you're working on a family like this, in sketch mode essentially, that it won't select other things. It won't try to select the sink or the walls or anything else, only the parts of this cabinet that I'm working on. So I can easily find the void, there it is, and adjust it without worrying about other things getting in the way or being adjusted accidentally. So again, the void just needs to come under that lip there, and there we are, done. Go back to 3D. There we are. That's a good point, yeah. You can lock them together. That's a bit more advanced than we're going to look at. But yeah, you can. Revit's amazing in that way. That's really where Revit's the strongest of any program. But probably the easiest approach here would be to adjust the sink. So get the sink into the position you want. So I want to move it to the right a little bit, and then you can easily just come back and edit your family. Oh, no, you don't have to. It does that for you. But it's thinking in the right way. I'll just show you that option because you'll see you've got join, and that effectively, it's like union, joins things together. But then for voids, you've got this special tool, which is cut geometry, and that's what you use. If you need to tell it, you can see there, if you need to tell it which things you want it to cut, you can pick them with that. But you can see there, I didn't use cut because it automatically will cut out things if they're overlapping. So the basic rule is if you draw a void over something else that's solid, it'll cut that. But if you make a void beforehand, or if you make it in empty space, and then you make solids or move solids there afterwards, that's when you've got to use cut. And that'll become clear to you when you well, I'll just show you very quickly. When you make a void, and again, it's not cutting anything. This void is obviously to one side or not over the cabinet. So when you make a void like that, it'll be orange. You can see there. So if it's orange, that means it's not cutting anything. But if I then bring it across, so it's still not cutting, but then I can use cut and choose the void and then the solid, and then it cuts it. So that's when you use cut. Yes, all the time, yeah. Because there'll be times when you only want the void to cut certain things. And so you can see in this case, the void's overlapping the doors and the bench and the carcass, but it's only cutting the bench. But I can tell it now, okay, I don't want you to just cut the bench. I want you to get the, let's say the carcass behind the doors. So that works. But it's still not cutting the doors. Yeah, but look, later I might, because for the sections it can be good. So yeah, so join's a good option here, but no, I'm not going to do that just yet, because it doesn't really affect the way they look from the outside here.
So is it more something a bit more complex with these joints? Like all cuts to be complex, like even some wall storage might be.
Oh, you know, look, to be honest, I use it for almost everything, but it's just an efficiency thing. There's no point doing it at this stage because I know these things are going to change. But later, yeah, you'll probably find you will join everything. So I'll spend more time on that. You can, yeah. Exactly. So there is an unjoin option. Yeah, that's true, it's true. So yeah, so you've got unjoin geometry, if you click on the down arrow there, and then the same with cutting. So you've got uncut as well. So if I don't want the void to cut the sinks anymore, you've got that. Yeah, sure. Yeah?
How did you get to that, like, getting to draw the lines without throwing it on the bench to go to
I do reference planes to set out the cupboard doors.
Doesn't it go on top of the bench if it's already drawn, though?
No, you can draw in any order. So, yeah, so, is that what, so,
I understand how to only draw on the cabinet without throwing on the bench top as well. Like, you know how normally you have layers or something like that?
yeah, no, so it does the layers for you. So, yeah, if they're all one category, that's the same as all being on one layer. So these are all, let's finish it. So these are all casework. So if you wanted it to be partly a different category, then it couldn't all be one object. That's a bit of a Revit thing. Sure. Yeah, model in place. That's where, yeah, if you might have missed that at the beginning. So under component, you go to model in place. That's,
There's a reader on.
yeah, so after you still need to choose a category always, so I'll just choose something, and then the name again.
So it doesn't matter what you choose.
No, it does, yeah, it does, so we won't do that. So
What do you choose?
model in place,
And
then you choose the category that you need. Right, so you need to know what these categories are for. And so in this case, I was making casework. Right, that's going to built in. The name, that's up to you. There's just a name for that object that we're making. Yeah, and then you'll see extrude. Yeah.
You mentioned that we extruded, we took the measurements from the floor level.
That's right, yeah.
Can you extrude things from the floor, or do you have to
You
start
can.
from the floor?
No, you can. Yeah, it's good to be thinking like that. So it's a bit more advanced, but I'll show you quickly. So if you're interested in trying an extrusion that's from a different plane, yeah, that's a really good example. Yep. Yeah, yeah, no, that is good. It's good to be thinking of that. So that's great. So I'll show you that.
How come that's slightly off? Oh, yeah.
Yeah, I just moved it. That's all right. Okay, so yeah, I was just giving an example there. So that's really good. Now, this is much more advanced than I'd normally do at this stage, but since you're thinking about it, that's good. So let's look at, a niche in the wall. Now, if it was just a rectangle, you probably can think already, well, an extrusion flat coming up would do that. But I'll do a shape that you couldn't make with a rectangle from the ground. So, again, a bit more advanced. You don't have to do this, but if you want to try it, again, model in place. Now, because I'm making a niche in the wall, I'm going to make the category walls. So, like I said before, you can work out the categories hopefully just by reading through the list, but generic models would work just as well here. If you're not sure, generic models. But here again, walls is what I'll use, and to help me, I'll call it wall niche. Okay, so this is the part that's, again, a bit beyond what I'd normally do, but it's great that you're thinking about it. So this button here, set, is one of the most common options you get for setting work planes. Unfortunately, there are others, but this is the main one. So set, I'll choose.
Can I ask a question?
Yeah, sure,
If
sure.
you haven't tiled your wall and you put the niche in, when you do tile it, it's just going to pick it up from the niche, right?
Yeah, absolutely, yeah. So here, I'm just going to click set, and then it comes up with this nice thing. So it's the option for the work plane, and there you can see in the list of names, we've only got the levels. So that's not going to help. We need to go to pick a plane, click OK, and then I can pick the surface of that wall. I'll just change the angle so you can see it a bit better. Also, just zoom out a bit. Okay, so notice how it's highlighting the whole inside surface of that wall. So that's going to be my new drawing plane. It's like I'm picking my drawing board up from being flat on the ground, stick it on the wall, so it's vertical. Okay, so now I'll go and make a void extrusion. And like I said, I'm going to make something that we couldn't make from the ground. So what am I going to do? Just something maybe like diagonal. There we go. Then it's got to be closed. And, well, let's make it make sense. It's a shelf at the end of the day, so I'll probably need to have one vertical line in there. And, well, what I should be showing you is what this looks like in section. So just like anything else, you can change views while you're working. And at first, it'll definitely make it easier for you to look at the orthogonal view. In other words, at a right angle, like a section. So now I can get some proper shelves in there. That kind of makes sense now. So, yeah. Okay, but can you see that wouldn't be possible with an extrusion from the ground? It's an extrusion, obviously, but not from the ground. So then I'm going to make the extrusion start minus 150, and I'm going to make the extrusion end 150, just so I don't have to think about the direction, because when you go up to vertical, you often won't know which way's forward and which way's backwards. You can work it out, but I don't want to have to do that, so I've made it 150, so it's going to go back the same amount it goes forward. And you'll see that in a second. I'll finish it and then you'll see it. So I'll finish this now and then show you in 3D. There we are. So you can see how it's sticking out, but it's also going back into the wall. Harder to see that, but it is going back into the wall. Put to one side. Okay, and then it hasn't cut it automatically because that's a wall. It's not part of my family. But that's when you can use the cut tool to force it to be, or to force it to cut. So with cut now, I'll choose the void, and then the wall. There we are. Finished model, and we've got a recessed cutout. Yeah. Yeah. Oh, it's a system family, essentially. Yeah. Yeah. So this is again. We'll go further with this later, but it's a bit of a technical thing in Revit. These things like walls, roofs, ceilings that you've been making, at first you won't think of them as a family. But technically, almost everything in Revit is a kind of family. And you'll see when you look at a wall, go to Edit Type, it's a system family. So it's a special kind of family.
You did make it a wall, like, when you
Yeah.
like, sort of came through
Yeah.
the model.
Yeah. Yeah, basically, that's it, exactly. Yeah. It's a custom, so it's a really good option actually, because it means you can make your own version of something. You can make a wall that's any shape you like, and it's still considered by Revit to be a wall. And really, these system family walls are just for the more common walls, the everyday vertical walls that don't do anything interesting. And then, yeah, the ones that you make are the model in place walls. And so the only issue really is when you do things like voids, you've got to tell it to cut it manually. Otherwise, it works really well. And so, well, just to finish off there, if you've ever tried to make or want to make a wall that isn't vertical, if it's sloping or you want it to curve in unusual ways, no problem to use model in place to make walls. And then you can make pretty much any shape of wall you can think of. And Revit still thinks of it as a wall, even though you're not using the wall tool.
So if you use model in place to make a really nice vanity and you use it in this project,
Yep.
if you had another project that you thought, okay, I really
Yep.
like that vanity I made for another project.
Yeah, yeah.
Is it like a component in terms of you
Kind of.
take it and copy it into?
You can. There is a way of moving it from one project to another, basically copy and paste. But it's not perfect to work that way, because again, that model in place tool is really meant for one-off things. And if you know in advance that it's something you want to use repeatedly, you're much better off using the place components that you load. And we haven't got into that yet, but you'll be making your own before long. And so when you go to load a family, you can see, well, again, furniture is a good example. When we look at, let's actually look at, I'll just go to furniture. Look for Casework there, but it's not there. So I'll just look at more storage. So all of these things, they're actually made the same way. You've got the same tools, but you make it in its own file, and that makes it much easier to manage when you're going to use it repeatedly. And that's the thought process. But at first, that can seem a bit abstract, and so it's good to make as many as you can and get used to the modelling tools with model in place, and then later we'll go into these family files, which exactly, yeah. That's a bit more involved, but yeah, that's the right way to think. That's good.